Suppose we were designing a sports stadium and we wanted to know how many seats were in this wedge-shaped corner section of the stadium. What do we know about this stadium? Well, let's assume that the first row has 18 seats and that each time we move back a row, we're adding one more seat. We have 16 such rows. How could we find the total number of seats in the corner section? So this is a little different problem than what we were looking at before. Instead of just trying to figure out how many seats are in a particular row, in other words, that's going to be our nth term, now we want to add everything up. So let's think about that a second. Let's just find out, for example, how many seats might be in the last row. This would be a problem where we would first say we have a sequence starting at 18, and we're going to add 1 each time. Okay, and we're going to go 16 times. And so we have a sub 1 equals 18, we have d equals 1, and we have n equals to 16. Okay, so the 16th row should have how many seats? Well, it's going to have 18 plus 1, oops, put the 1 outside here, 16 minus 1. Okay, d times n minus 1. And if we do the math on that, we have 18 plus 15, and that should be 33. So there's 33 seats in the last row. But how many are there in the total from a sub 1 all the way up to a sub 16? That's what we're trying to find out here. I'm going to give you the formula first to show you that the answer is actually pretty simple. And then what we'll do is take a look at some new notation that we need to take care of. Which is a compact way to talk about how to add up a series of numbers. And so going back to the actual sum, this is the formula that we want to use. And so there's a lot of familiar stuff here. So let's look at n. n in this case is going to be 16. A sub 1 is the first term in the sequence, and we know that that is 18. And a sub n is going to be the last term of the sequence. Remember, a sub n is the nth term, n is 16, and so this should be a sub 16. And we found that on the previous slide to be 33. And then we divide that sum by 2. So let's see what we get here when we put this into the calculator. We get a grand total of 408 seats. And so we did that pretty quickly and pretty easily just by knowing the number of seats in the first row, the number of seats in the last row, and how many rows that there were. This is a notation that we use to specify the sum of terms in a sequence. This is called a series. So a series is a sum of terms of the sequence, and we use what's called sigma notation. This symbol right here is the Greek letter sigma. And sigma is the Greek's version of the letter S, and S is for sum. So that all makes sense. Now, what is all of this stuff? This looks pretty complicated and mysterious, but it's actually pretty simple. The symbol itself means we're going to be adding up a sequence term by term. Each term of the sequence is given here. Now, for right now, this is just telling us that we have a particular number, and it's the kth number of the sequence. K, I like to think of as a counter, and I'm using a misspelling on purpose. Why? Because it's easier to remember if you have something goofy. Okay, so K is a counter. The math term for it is index. Okay, this is called an index, but I'm not going to worry about that. And the counter does exactly that. It counts from 1, or whatever this number is down here. We're starting at 1, all the way up to n. So, how does this work? This particular notation, this particular formula here would tell me to do the following. Take k equals 1 and plug it into the expression. Well, this expression is pretty easy. That gives me just a sub 1. After I get that value, make k 1 higher than you have. So now we're going to change from 1 to 2. And we're going to do the same thing. And we're going to add everything previous to it. And we're going to change 2 to 3. And we're going to change 3 to 4, and we're going to keep on doing that until we get to k equals n. The last time we go through this loop, last time we go through this process, k is equal to n. So this is basically pronounced the sum from k equals 1 to n of a sub k. So that would be all of this. Now, since we don't have a formula here that gives us an actual number, we would still need to have a sequence here so that we know what a sub 1 is, a sub 2, a sub 3. But the idea is simple, that we're going to calculate something here and we're going to add that thing up and continue to add it, making a running total until we get all the way up to n. So let's look at a specific example. This is basically telling us how to find a sub k. And how do we find a sub k? We plug in k into this formula and we get the answer we're looking for. Well, the good news is we don't really have to do this repetitious process, even though that's what's really happening in the math. We know that to add up all the numbers in a sequence from the first one to the nth one, all we have to do is follow this formula. We have n times a sub 1 plus a sub n divided by 2. So we really only need to get the first term, the last term, and the value of n. Well, if you recall, k is going to count from 1 up to n, so it appears that our n value is pretty easy to find. It's just the number that's on top here. Okay, so n is going to be 10. What else do we need? A sub 1. A sub 1 is the first number in the sequence. When k is equal to 1, we get a sub 1 from here. So if I plug in k equals 1, I get 16 plus 4 times 1 minus 1, which is 0. 4 times 0 is 0, and 16 plus 0 gives us 16. And then the last thing I need is the last term in the sequence, which is a sub n, which is a sub 10 in this case. And how do I get that? I'm going to get that by plugging in k equals n. Okay? I don't even have to really know what my d is because, at least in this formula, it's already there. All I have to do is plug in k into this formula. So the nth term, the 10th term in this case, is going to be 16 plus 4 times 10 minus 1. 10 minus 1 is 9. 4 times 9 is 36. 16 plus 36 is 52. And so I'm going to get 52 here. Now I just apply the formula. My sum is equal to n over 2 times a sub 1 plus a sub n. So I'm going to have 10 times a sub 1 was 16. A sub 10 is 52. Divide all that by 2. And if I do all that, I'm going to get 340. So we would have 340 as the sum for this sequence right here. Okay, let's try another example. Step 1 was to find the value of n. That's really easy. It's this guy right up here, n is 21. Next, we're going to find the value of a sub 1. We're going to do that by plugging k equals 1 into the formula, so let's just write it out. Hate when it does that. Okay, negative 3 plus 5 times 1 minus 1, that's 0. 5 times 0 is 0, so a sub 1 is negative 3. We need a sub 21. That's going to be negative 3 plus 5 times 21 minus 1 when I plug in k equals 21. That's equal to negative 3 plus 5 times 20. 20 times 5 is 100, minus 3 is 97. And then the last thing we do is we say that the sum is going to be equal to n times negative 3 plus 97 divided by 2. That's 21 times 97 minus 3 is 94. If I divide that in half, I get 47. And then if I take 21 times 47, I get 987. Okay, one last example. If you were thinking on those previous examples that a sub 1 was easy to find because it was the number that was at the beginning of the sequence, you were right, except now we've got a little different form of the equation here. And it really doesn't matter because, again, we just have to plug in 1 into the formula to get a sub 1. So let's start with the value of n. That's up here. N is 60 in this case. So we're going to add up the first 60 terms of this sequence. The sequence starts at a sub 1, which is going to be 3 times 1, k is equal to 1, minus 13. That's 3 minus 13 is negative 10. Let's find a sub 60. That's going to be 3 times 60 minus 13. 3 times 60 is 180 minus 13. That gives us 167. And then finally we get our sum, which is going to be 60 times negative 10 plus 167, all divided by 2. 167 minus 10 is 157. If we divide that by 2 and multiply by 60, put that in your calculator, you get 4,710 for your answer. So just because this looks different than any of the examples doesn't really matter. We just plug in k equals 1, k equals n. That gives us these two numbers. N is up here. Put all three of those into our equation and we get the answer.